forces pushing you through the day, every day.
Sunkist, the science kid.
Why do some objects, they go really far and they go really fast when I push them, like this chair? While some objects, they don't go as far or as fast, like this car. More importantly, what's making all these things move? It's a thing called forces. It's a phenomenon that makes everything around you move. It's the reason why you're touching the ground. And it's the reason why you can push and pull a door open. It's what makes things move. Now, how can we tell that objects with higher mass have a lower speed than objects with lower mass? Well then, consider the following.
For this Consider the Following experiment, we're going to have Gary push Sunkist and JD, who are two different masses, with the same amount of force and compare their acceleration. First, let's compare our two individuals. According to this experiment, Sunkist, who has less mass than JD, went further and accelerated faster, and JD, who has more mass than Sunkist, went slower and didn't go as far. Thank you for joining me on Consider the Following.
Now, as I demonstrated before, when I push this chair, it'll go farther than when I push this car. Now, there's a correlation between the mass of an object and the force being applied to the object. The man who figured this out, it goes by the name Sir Isaac Newton. He said that the force of an object depends on the mass of the object, the speed or acceleration of the object. This is known as Newton's second law of motion.
Experiment you can do at home is by using two balls and a round. First, get two balls, one larger than the other. Newton's second law explains that a heavier mass requires more force than a smaller mass. So when I rolled down this ball, the larger ball rolled down, hit the smaller ball, and made it accelerate. But when I rolled down the smaller ball to hit the larger ball, it'll have less impact, making it accelerate not as much.
They see me rolling, they hating, patrolling and trying to catch me riding dirty, 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 trying to catch me riding dirty.
Did you know Newton's second law states that force equals mass times acceleration? And one more thing, may the F equals ma be with you.
As I demonstrated before, this chair is much easier to push than the car. Now, the reason behind this is mass. Mass is how much matter there is in an object. This car weighs well over 2 tons, while this chair weighs just as much as a kindergarten student. Now, if I really wanted to push this car, I really have to force it.
Haha, that's really funny.
Yo, you still haven't started yet? We need to get to work right now. This is due tomorrow, alright? Give that to me. So as you can see from that last cutscene, that boy was already working pretty hard, but that bully came along and forced him to work even harder than he already is. That's an example of Newton's second law. Oh, an example of Newton's law of motion is a rocket ship.
A rocket ship is an example of a real-life situation where Newton's second law is applied. The thrust from the liftoff of the rocket creates enough force to overcome the mass of the rockets. So if a rocket were to go to the moon, you would need enough force to lift the mass to produce an acceleration worthy of doing so.
We should take Bikini Bottom and push it somewhere else!
Another example of Newton's second law in real life is dog sledding. Dog sleds require a whole group of dogs to move a sled of a certain mass. The dogs altogether need to apply enough force to overcome the mass and accelerate, to eventually move the sled at a fast pace. This can be represented by the equation F equals mass times acceleration. Thanks for watching the video, and I got one more corny joke. Anything that doesn't matter has no mass.
The second law is all about a simple formulation. To get the force, just multiply mass and acceleration. If that's too much to say, there is an easy way. Try this abbreviation for this simple formulation.
F equals M-A, F equals M-A, F equals M-A. Now that's the abbreviation. F equals M-A, F equals M-A, F equals M-A.
Force equals mass times acceleration. Force equals mass times acceleration. Acceleration.